Section 8 is factoring by grouping, the last section in the chapter. And once again, I'm going to step outside of how the book would typically try to get you to do these types of problems and kind of go my own route. But it kind of tailors itself nicely to something else that I stepped out of the book for. So you already know kind of how to do this, which is nice. So factoring by grouping happens when we have more than just a trinomial. So when we have more than three terms, so like four terms, which is what you see already on this screen. So we're going to be using GCFs repeatedly, as you see right here, to be able to factor by grouping. And actually, once you see how I'm going to be doing this, factoring by grouping actually doesn't even happen. We just are going to be using, I'll just give it away, we're going to be using the box to be able to do this process. So factoring by grouping is what the book does, and I just completely ignore that, and I'm going to be showing you how to do this by using what you already know how to do, which is the box. But again, remember, step one in any factoring problem is always look for a GCF to factor out first, okay? So we got to remember to do that. Look for GCF. We must pull out the GCF if there is one before we do any factoring otherwise, because if we don't, we will get a wrong answer, okay? So no matter what method we're using, even if we're using the books method, we're going to have to pull out the GCF first. Otherwise, we're going to get something wrong, okay? Now, when you have four or more terms, so look at this polynomial that we have here as an example. There's four terms there. You're going to need to factor by what they call factor by grouping, okay? But for us, what we're doing is we're going to do this other method, which is the box. So here's how it's going to work. What we're going to do is draw our box. And when I taught you how to do the box, I told you put the terms in the box just like you're reading a book. And we read a book from left to right, top to bottom, right? So we start up here and we finish down here on the page. So top to bottom, left to right, top to bottom, we're going to put the terms in the box just like reading a book. So left to right, top to bottom, and we're going to put those in the box from highest degree to lowest degree. So for us in this polynomial, by the way, is there a GCF here? The answer is no, other than 1, 3, 12, 2, and 8. There's no greatest common factor other than 1. So we're good. We can go into the box. So this term here, the n to the third, n to the second, n, and then there's a degree of 0 there. So the highest degree term is the n to the third. It goes in the top left. And then we, just like reading a book, we go to the right with this negative 12n squared. And then we're at the end of our line, so we go down to the next line. So this 2n, and then we go to the right, and then we have our negative 8. Okay, so just like reading a book, from the top, we go to the right, we end our line, we go to the bottom, go to the right, highest degree to lowest degree, and so on. Okay, so we set up our box. So now what we want to do is factor out our GCFs across each row and down each column. And remember, the lead box determines the sign of the GCF that you pull out. So for the top row, okay, for my top row, the GCF is 3n, and the lead box was positive here, so I'm just pulling out a positive 3n. For the bottom row, the lead box here is positive, so I'm pulling out a positive 2. For the first column, I'm pulling out lead box is positive again. The GCF is 1, and then there's an n in both, so just 1n. I'm only writing n. And then for the second column, I'm pulling out my GCF. The lead box here is negative, so I'm pulling out negative, and then the GCF between 8 and 12 is 4, so it's 4. Okay, and that's it. So just like before, we're writing our result. We have 3n plus 2, and we have n minus 4, and we're done. That's the answer. Oh, you know what? I had one mistake. There's actually an n cubed here and an n squared here. My mistake is the lowest exponent between 3 and 2 is this is a 3n squared. So you know what? I make mistakes sometimes too. So that was a 3n squared. So that means my answer here is 3n squared. So 3n squared plus 2 times n minus 4, that's our answer. Okay, so watch out. Sometimes we can make simple mistakes with our exponents. Okay. So our second example is this one. We have 8t cubed plus 14t squared plus 20t plus 35. Again, the first thing I'm going to do is I'm going to look to see if I have a GCF to factor out with 8, 14, 20, and 35. Let's see. Do we have a GCF? Nope. So we're good. We can go on to setting up our box. So again, I'm just going straight to our box. The highest degree term is 8t to the third. So that goes in the first box. To the right, the next highest degree is the t squared. So that's 14t squared. And then next row, so we have 20t, and then finally the 35. So now we're going to pull out our GCFs. For the top row, I'm not going to miss my squared this time. We have between the 8 and the 14, that would be a 2, and then t to the third and t squared. The lowest exponent on those guys is 2, so it's going to be t squared that I pulled out. And then on the bottom row, we have 20 and 35. The biggest number that goes into both of those is 5. So that one's good. And now we have the first column. So I'm looking in these two boxes here, and we're going to have a positive, and the biggest number that goes into both 8 and 20 is 4. And then t to the third and t, the biggest number that goes into both of those, the lowest exponent between t to the third and t is just t to the first. So it's 4t. And then finally, we have 14t squared and 35. There's no t in both of those boxes, so I'm just pulling out a number. The biggest number that goes in both 14 and 35 is 7. So I'm pulling out a 7. Okay, so I'm ready to write my answer. I have 2t squared, a positive 5, so I write plus 5. And then I have 4t and a positive 7, so I write plus 7. And we're done. That's it. Okay. Now, the book's method with factoring by grouping is what it's called. Would have you be doing a lot more work than this. This is very simple. We've already been doing it, so you're already familiar with it. Hopefully you're good. Okay. Now, what I say here, watch out when you group and there's a minus sign between the groups. If we were doing the book's method with factoring by grouping, we would have to do something extra here. But because we're not doing that, we don't have to worry about it. All we have to do is go straight to, do I have a GCF? The answer between 2, 12, negative 5, and negative 30. With that 5 sitting there, no, we don't have a GCF, so we'll go straight to the box. We don't have to do any extra work. So we have the highest degree term, 2r cubed. The next highest degree term, 12r squared. After that, negative 5r, and then negative 30. Now we're just pulling out the GCFs. So for the top row, it's definitely a 2, and then r squared. And then for the bottom row, the lead box there was negative, so it's going to be negative. And then 5 and 30, the biggest number that goes into both of those is 5. Now for the first column, we're going to have a 2 and a negative 5. The biggest number there is going to be just 1. But then we have r cubed and r, so the lowest exponent that goes into both of those is just r to the first. So it's 1r. I'm just writing r. Then for the last column, we have 12r squared and negative 30. Since there's no r in both of those boxes, I'm not going to pull out an r. The lead box is positive, so now it's just a matter of 12 and 30. The biggest number that goes into both of those numbers is 6. So I'm going to write down 6. So now I can write my answer. I have 2r squared minus 5 and r plus 6, and I'm done. And that's it. We didn't have to do any tricks. I didn't even have to pay any attention to that thing right there because we're not doing the book's method. So We're just saving time. Okay, pretty nice. So once again, the GCF is always the first move. I cannot stress it enough. Look for a GCF. It doesn't matter what method we're doing. If there's a GCF, you have to pull it out every single time. Otherwise, you will get the answer wrong. So in this first problem, is there a GCF here? The answer is, of course, yes. Okay, so we need 4, 8, 12, 24. What's the biggest number that goes in all those numbers? It is 4. Then we look at the letters. There is a y in every single one of those terms. So the smallest exponent that is involved in every single one of those is just y to the first. So I'm pulling out actually 4y. That's the GCF. Okay, now we're going to write what's left over. So we open parentheses. Remember but when we factor out a GCF, that's like dividing. So we have the 4y to the fourth here divided by 4y. Well, 4 divided by 4 is 1. Y to the fourth divided by y, basically we're subtracting the exponents there. So 4 minus 1 is 3. So we're going to write y to the third. Then negative 8 divided by positive 4 is going to be negative 2. And then y to the third divided by y is y squared. So we have y squared. So negative 2y squared. Then we have positive 12 divided by positive 4, which is positive 3. And then we're going to have y to the first. And then we have negative 24 divided by positive 4, which is negative 6. And then y divided by y. We had a y there. We pulled out the y isn't there anymore. So that's what we get. Now, inside the parentheses, notice that there's 4 terms. So that means we're going to do what the book would say, factor by grouping. But we're outsmarting the book. We're going to use a box. So we still have this little GCF hanging out off to the side. We're going to let that go ahead and sit there for a little bit. And we're going to go ahead and use the box. So we set up our box. And highest degree to lowest degree, we have that y to the third. We have a negative 2y squared. We have a 3y. And we have a negative 6. And then we're off and running with our GCFs. So for the top row, we're going to have, looks like just a 1, but y squared also. And then for the bottom, 3 goes into 3 and 6. It's going to be a positive 3 because the lead box is positive. Then for the first column, we're looking at, looks like a 1 for the numbers, but a y for the letters. And then for the second column, notice that the top box there, the lead box, is negative. So we're going to pull out a negative, and then between 2 and 6, the GCF there is 2. So, and there's no y in both boxes, so we're not pulling out a y. So that's it. So now we're going to write our answer. So we have the original GCF sitting here. So we have 4y. We got to bring that one along. Now we're going to have y squared and the positive 3, so plus 3. And then across the top, we have the y and then the negative 2, so minus 2. And that's our answer. Okay? Again, we don't have to worry about any tricks that the book is trying to make us have to do to make sure that we can pull out all of our GCFs and everything else along the way. We don't have to worry about extra negative signs and switching signs and keep change. We just go straight to GCF. Now inside, do the box, pull out our GCFs in the box, and then go to our answer. Okay, it's very clean, very easy to do. Okay, so then this one, again, our first move is always GCF. So do we have a GCF here? Well, first of all, I see an H in every single term, so I can definitely pull out an H. So now we can look at the numbers, 6, 9, 12, 18. The GCF can never be any bigger than the smallest number. So I look at the 6. 6 goes into 12 and 18, but not into 9. 9 is odd, so I know 2 can't go into 9. The other factor of 6 is 3. So it's 3. So I'm pulling out 3, and then I already said H. So we're pulling out 3H. That's our GCF. Now open up parentheses. What's left over? Remember, this is like a division problem now. 6 divided by 3 is 2. And then subtract the exponents on the variables. So h to the fourth divided by h to the third. 9 divided by 3 is positive 3. So we're going to write plus 3, and then it's h squared. And then 12 divided by 3 is 4. So we're going to write plus 4. And then it's h. And then we have 18h divided by 3h, which is just going to be plus 6. Close the parentheses. Remember, we started with 4 terms. In the parentheses, we're going to have 4 terms. Okay, you're not going to lose a term. Even if everything got factored out by the GCF on a term, you're going to have 1 left over. Okay, so every term will still be there. It'll just be 1 if you pulled everything out. Okay, so we have the GCF hanging out. We're going to have these 4 terms here going into a box. So we set up our box. Highest degree term, 2h to the third. Then 3h squared. Then 4h. And then 6. And then GCFs. So for the top row, looks like between 2 and 3, just 1. But then we have h cubed and h squared, so we're going to have h squared. And then for the bottom row, looks like 2. For the first column, we're going to have between 2 and 4. That's going to be a 2. And then h cubed and h, it's going to be 2h total. And then for the last column, it is 3. Okay, so now don't forget the GCF. We have 3h times, and then what we pulled out, we have h squared plus 2 and 2h plus 3. If there's anybody out there that's ever done factoring by grouping, if you're looking at this right now, you're probably saying, oh my God, this is so much easier than factoring by grouping. I can't believe I ever had to do it. And right now they're nodding their head. Yep, he's right, because factoring by grouping is no fun. Okay, trust me. So here's a question for you. Is 6 minus a, is this the same as equal to -1 times a minus 6? Well, what we can do to see if it is or not is we can take the -1 and do what it looks like. We can distribute that -1 in, and if we do that, we get -a, and then -1 times -6 is positive 6. So we have -a plus 6, and then we can remember that we have this property that says if we do addition, we can reverse the order of addition, like 2 plus 3 and 3 plus 2, those are the same thing. We have addition going on right here, so that means we can reverse the order. So we can say -a plus 6 is the same as 6 plus -a, which is the same as 6 minus a. So are they the same? Yeah, they're the same. Okay, so that just answers that question. And then here it says sometimes it's useful to factor out a -1 to make common factors appear. Remember, this was written in the spirit of using the book's factoring by grouping. So again, we don't need to do that here. However, it is good to know that you can factor out a -1 if you need to ever, but we don't need to in Algebra 1. I will say, though, that if I had something like -x squared plus some stuff, okay, in order to be able to factor, this term right here needs to be positive. So if you ever encountered some problem where it said factor this and you have a -x squared term, you're going to want to factor out the negative from the whole trinomial as if it was a GCF. Okay, so just keep that one in mind. So you would wind up then with like -1 or maybe negative the GCF and then open parentheses and write, so then it's positive x squared plus blah, blah, blah. Okay, so that's like the idea. That's where this hint right here actually does matter. But anyway, we can continue on with what we've been doing and we can still use a box even though we see extra letters here, multiple letters. Okay, so we're going to go, is there a GCF here? So we have 2, 12, 42, but then this 7 right here kills the number GCF. And then we have M, but no M there. A K here, but no. So there is no GCF. So we're going to go straight to the box. And when we set this one up, again, remember, highest degree term to lowest degree term. So this term right here has a degree of 2. Since there are 2 variables here, the exponent on each one is 1. So 1 plus 1 is 2. The degree of this term is 1. The degree of this term is 0. And the degree of this term is 1. So I'm actually going to rewrite this one in standard form. We have 2mk minus 12m, and then minus 7k, and then plus 42. Just so that we see the order that these terms need to be written, okay? Now, I realize that this is not, the letters are not written in alphabetical order, but because of the way that the letters were given to me, the M was written before the K in that term. I wrote the M before I wrote the K here, okay? That's not super important, but that's the way that I did it because the way that they wrote the letters on the original problem. So because of that now, I'm going to write my highest degree term, 2mk, and then the negative 12m goes here. And then the negative 7k, because that also has a degree of 1. And then the 42 has a degree of 0. That's how we're setting that one up. Okay, still highest degree. Read your book down to the lowest degree. So now we're going to go ahead and factor out our GCFs just like we've been doing, even though there's 2 letters involved here. So for the top row now, 2, negative 12. There's a GCF there of 2. And then we have an M in both of those. So I'm actually pulling out a 2M. Now for the bottom row, this is one straightforward. We have a negative 7 here. So we're pulling out a negative. And then between 7 and 42, the GCF is actually 7. So we pulled out a negative 7 that time. Now for the first column, we're looking at 2 and negative 7. So the GCF there is going to be 1. But then we have a K in both of those. So I'm actually pulling out 1K, which I'm just going to write K. And then for the last box, or the last column, I should say, the lead box is negative, so I'm pulling out a negative. And then between 12 and 42, 2 would work, but that's not the biggest number that goes into 12 and 42. It's actually 6. 6 goes into both 12 and 42. And now we don't have an M in both boxes, so I cannot pull out a letter there. It's just going to be negative 6. So that's it. We did not pull out a GCF, so I'm just going to go ahead and write my answer. We have 2m minus 7 times k minus 6, and we're done. So that's the gist of it. I think we've seen enough examples at this point that we can probably, like this problem right here that we just did, is it really exactly the same as this one? So I'm just going to go ahead and skip that one. And this problem to the right of that is exactly the same as ones that we've already done. So I think we can probably get away with skipping both of those. There is the last problem here on here that I want to do still. I think we can probably do that because it has one more example with a GCF. So let's go ahead and do that one. So here it is. This problem has some pretty big numbers in it, and that's another reason why I kind of wanted to look at it. So the first thing we're going to do always is look for a GCF. And I see a lot of big numbers here. I see an M in every single term, so I'm definitely going to pull out an M. And then I'm wondering, let's see. So the smallest number up here is the biggest that we can possibly pull out. The smallest number is this 42. And 42 is a weird number. 42 doesn't go into 60 for sure, so I know it's not 42. So I'm going to think about numbers that go into 42. So like 6 and 7, let's see, 14 and 3. So, and then 2. So 14 is too weird. That's probably not it. So 7 doesn't go into 60. So I know it's not that. 6 goes into 60. 6 definitely goes into 300. So 6, so I look at 6, and 6 has factors of 2 and 3. I already know 6 goes into 60. I already know 6 goes into 300. The question is, does 6 go into 210? If it does, then I know that it's 6, okay? So here's how I do this. 6 has factors of 2 and 3. If 2 goes into 210, which it does because 210 is even, if 3 goes into 210 also, then 6 goes into 210 because 2 times 3 is 6, okay? So does 3 go into 210? And the answer is actually yes, and there's a trick. So if you add all the digits in a number and that sum of the digits is divisible by 3, then the number itself is divisible by 3. So 2 plus 1 plus 0 is 3. 3 is divisible by 3, therefore 210 is divisible by 3. So that means that 6 goes into 210. So my GCF is actually 6M. I don't know if you follow that or not, but it's true. Okay, so now 60 divided by 6 is 10, and then we have m to the third. Minus 300 divided by 6 is 50 m squared. And then 42 divided by 6 is 7. So we have minus 7m. And now is the tricky part. I did not actually figure out what 210 divided by 6 is, so I got to figure that out. But it is 35 plus 35. Okay, so now I still have to deal with this group of 4 here. So, but the nice thing is I can just go straight to the box. So box, and then highest degree to lowest degree, so 10m to the third. And then we have minus 50m squared, and then minus 7m, and then 35. Highest degree to lowest degree, just like reading a book. Now, pull out the GCF for the top row, and that will be positive 5, and then m squared. And for the bottom row, that will be negative because the lead box is negative, and 7. And for the first column, we have an m for sure, and 1. It's just m. Okay, and then for the last column, we have negative because the lead box is negative, and 5 and 35 is 5. No m on that one. So now we have our answer. We have our GCF, don't forget, 6m, and then it's 5m squared minus 7, and then, wait a minute. Oh, I made my second mistake. This is a 50. I accidentally wrote 5 instead of 50. So that's going to change this GCF. This is actually 10 and 50. This is not 5 here. Sorry, guys. This is 10. So that's going to change my answer over here. See what happens? I'm trying to go fast. So this is going to be 10m squared, and then the minus 7 is good. Let me double check my GCF here. Negative 50 and 30. This is good. Okay, so we're good now. I just wrote down minus 5 instead of minus 50. So then this is m minus 5. Okay, so there's our answer. So the point is, the book's version of section 8 is a little bit obsolete once you have learned the box method that we learned, because now we can use the box method to be able to do factoring by grouping, which isn't even factoring by grouping. It's just using the box in a smart way. Okay, so we have this summary down here, factoring polynomials. Remember, step 1 right here, and they even say it, is factor out the greatest common factor. You absolutely have to do that. And then after that, if the polynomial has two terms or 3 terms, you can look for the difference of squares, that pattern that we use. You can look for a perfect square trinomial, that other pattern that we use, and then factor them immediately. If they don't have that, then you can do undo FOIL. Okay, that's the first method that we had. So that one right there, I call undo FOIL. Okay, now if we don't have that, or we could also the box. Okay, the box method where we find AC and then we go on from there. Now, if we have 4 or more terms, so that's algebra 1 is just going to be 4 terms. We can group the terms in factor to find the common binomial factors. That is the box also. We don't group terms in factor. That's what I just taught you here. Now, as a final check, make sure there are no common factors other than 1. So that's step 1 up here. If you took care of factoring out your greatest common factor, you're not going to have to worry about number 4. So that's it. That is the whole chapter, and we're using a box a lot in this chapter. So make sure that you understand it. But the chapter is done.